Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we're going to find the area of a surface of a revolution. The curve provided to us is y equals radical 9 minus x squared, and we are interested only the part of the curve corresponding to the interval -2 and 2, and we are going to revolve that curve around the x-axis, and obviously we're going to have a three-dimensional object, and what we're interested in the surface area of that object. And at this moment, let me just remind you about the definition of the area of the surface of revolution. We have two different formulas here. One is for the curves written in terms of y equals f of x, and in the second one we have the curves written as like x equals g of y, so x is a function of y. So depending on which one provided in the question statement, go with that. And let's quickly check what we have in our case. I think we have the y equals f of x representation as you see, and we're going to use the very first formula for that reason. And let me also show you what kind of three-dimensional object you're going to get at the end. So here we go. This is where we start. We have the curve, the graph of the curve stuck in the interval, piece of the curve stuck in the interval -2 and 2. And we're going to revolve this around the x-axis. And this is the three-dimensional object you're getting at the end. So now we're interested in writing the integration formula to be able to evaluate the surface area of the three-dimensional object. So please have your graphing calculators ready, and let's hit the road. All right, let's take care of this problem. So we have the function radical 9 minus x squared is given, and we have the interval -2 and 2, and we're going to revolve the curve about the x-axis, or in other words, y equals 0. And we're going to calculate or evaluate the surface area of the three-dimensional object. So as the starting point, why don't you go ahead and have your graphing calculator ready and punch in y equals radical 9 minus x squared and plot it from -2 to 2 and see what it looks like. Okay, that's the first point or first part of this problem. We have to have a good visual to start with. And you should be able to get this blue curve here, and here are the x-min and x-max in your case, okay? So we have this big arc here, and we're going to revolve that around the x-axis, okay? So then you should be able to get a three-dimensional object, okay, after the revolution, and it should look like this. And I'm going to show you exactly what this looks like in a sec. Okay, but this is sort of like the three-dimensional object, and inside of that it's empty. It's just the surface, and we're asked to find the area of this three-dimensional surface. Okay, all right. Let me just show you what this three-dimensional object looks like. So here is what we start with: the curve, the arc in between -2 and 2, and we start revolving that around x-axis. Okay, so let's see what we have. Okay, so we keep revolving that, and we get this nice three-dimensional surface object, but we're interested in the surface area of this object here. Okay, so essentially we're going to find the area, surface area of this object, and we're going to find that by using the formula, integration formula. And for that reason, why don't we go back to the definition of the surface area and see what kind of formula is going to provide us this surface area. And here is the definition of the area of a surface of revolution. So we have two different formulas here. One for y equals f of x type curve, and the other one is x equals g of y type curve. One is written in terms of x, and the other one is written in terms of y. And if you're in the first case, you have 2 pi times r of x, which is in fact f of x, okay, in our case, especially for the problem that we're working on, okay, and then radical 1 plus f prime of x quantity squared dx. So here again, y is a function of x, and And in our case, y is in fact a function of x because the function that we're working with is a radical 9 minus x squared, and that is a function of x. So why don't we go ahead and use this formula to evaluate to calculate the surface area by evaluating this integral. All right, so let's write down the formula for the surface area. So it's going to be 2 pi integral from -2 to 2, and we have radical 9 minus x squared times 1 plus f prime of x squared dx, and then this is our f of x, okay? That's radical 9 minus x squared. So why don't we go ahead and calculate f prime here. So f of x is 9 minus x squared. That's radical 9 minus x squared, but I'm going to write it in the exponent form. And I'm going to use the power rule, generalized power rule, to take the derivative of this. So it's 1/2 9 minus x squared to the power of -1/2 times the derivative of the inner part, which is -2x. Okay, we can simplify 2 and 2 here and cancel out those and simplify the whole expression. All right, so let's write it minus x divided by, I'm using divided by because we have a negative exponent here. So 9 minus x squared to the power of 1/2, but this is equal to radical 9 minus x squared. Okay. So why don't we go ahead and write this all the way here. So this is 2 pi integral from -2 to 2. So you have radical 9 minus x squared and radical 1 plus -x, a radical 9 minus x squared squared. A lot of radicals. All right. So I'm going to erase this portion here, okay, because we don't need this anymore. All right. So now our task is to simplify the integrand and see if we can use the known integration techniques to find the antiderivative of the integrand. Okay. So all right, this is 2 pi -2 and 2, 9 minus x squared. I'm not touching that anymore, but I'm going to simplify inside of this second radical. Okay. 1 plus x squared over 9 minus x squared, right? And now what I'm going to do here is to find a common denominator, and so that I can replace this 1 by 9 minus x squared divided by 9 minus x squared. Okay? So if you do that, I can simplify inside the radical as 9 over 9 minus x squared. Okay? All right, so one more simplification to go. Here I can get rid of the radical sign and I can split that through or distribute that through the top and the bottom. So I can write radical of the top, radical of the bottom. This is particularly important because now we can cancel this radical 9 minus x squared by this radical 9 minus x squared. Okay. So what I'm left with inside here in the integrand is just radical 9, which is 3. So that's awesome because we can finalize this as like 2 pi -2 to 2 3 dx, right? And you can have the antiderivative here 3x, and this is from -2 to 2. Okay. All right, so let me just write down the final calculation right in the middle somewhere. I'm going to erase a little portion of that right now. All right, so let's use the fundamental theorem of calculus. So this is 3 pi 6 minus 2 pi 6 and minus And also this is 2 pi negative 6, okay? So 12 pi minus 12 pi, it's going to be 24 pi. That is the surface area of the object, three-dimensional object, that's obtained by revolving radical 9 minus x squared about the y-axis. Okay, so here you can go ahead and then conclude that this surface area here for the three-dimensional object is in fact equal to 24 pi. All right. All right, this is already a long video. I'm going to finish it right here. If you have any questions or comments, please send those to my way. And thanks for watching. I'll see you in another video. Bye.